right, so let's look at doing some curve sketching. We're going to draw this function using our first and second derivative test and all the information that we find out about it from that. Now notice I've set up kind of like this columns here, right, in order to solve this. Because remember, first derivative test is going to give me my max and mins, then my intervals of increasing and decreasing, and then the second derivative will give me any points of inflection and where the graph is concave up and concave down. All right, and at the end of this, I'm going to go ahead and graph it. So before we get started with the first derivative, let's just look at, there's one really useful piece of information that's very easy to get, and that's the y-intercept. So remember, when x is 0, you're on the y-axis, right? And so if x is 0 here, well, 0, 0, 0, minus 3, right? So my y-intercept is 0, comma, negative 3. All right, so that's actually my first piece of useful information because I'm going to be able to graph that y-intercept to help me draw the graph itself. Okay, now let's find first derivative and let's find some maxes and mins, and that will help us start to get an idea of the shape of this graph. Okay, so if I find my first derivative here, it's pretty easy. We got 3x squared minus 12x plus 9. And in order to find the maxes and mins, I'm going to go ahead and set that equal to 0. Well, notice I can just divide 3 out of every number, right? And this is going to be an easier quadratic to solve. And so now we have x squared minus 4x plus 3. Well, factor that is just going to be x minus 3, x minus 1. So we get two answers here. We got x equals 3 and x equals 1. Okay, now, in order to figure out our maxes and mins, right, I got to go ahead and put this back into the original function. I got to put these x values back into the original in order to figure out which one's max and min. And also, I need their y values so that I can graph them. So I'm going to go ahead and put in f of 1. And I'm going to do this by hand, but you see it's pretty easy with 1. We got plus 9 times 1 minus 3. So 1 minus 6 is going to be negative 5 plus 9 is 4. Minus 3 is going to get us right back to 1. So we have 1 comma 1. And actually, we're not sure actually which one's max and min yet. So let's take that out here. We got 1 comma 1, right? So 1 minus 6, let's double check here. Negative 5 plus 9 is 4 minus 3, so we got 1. So f of 1 gives me 1. Now we're going to input 3. That'll require a little bit more calculation. So 3 cubed minus 6 times 3 squared plus 9 times 3 minus 3. Now if you're really number savvy here, you can realize that 3 cubed and 9 times 3 is the same thing, right? Both of those are going to give you 27. And then here you have negative 6 times 9, which is going to be negative 54. And we have 27 here again, like I said, and minus 3. Well, 27 plus 27, 54. Minus 54, those are just going to cancel out, right? And I'm just left with negative 3. So my original thought was right, that this is a max, and then we're going to have a minimum at 3 comma negative 3. So I'm going to go ahead and record that, and now I have like another useful piece of information, right? So I'm going to go ahead and look at that. And now the last thing I need to do with the first derivative is I need to figure out intervals of increasing and decreasing, right? And so to do that, I'm going to use, well, x equals 1 and x equals 3. Those are going to be where it's going to change, right? And I'm going to use the first derivative test. Now, if I input 0 here, I'm not going to write this all out, but 3 times 0 minus 12 times 0 is 0 plus 9 is going to give me a positive. Okay, and if I input 2, you can see here I'm going to get 3 times 2 squared. It's going to be 12. Plus 9 is 21, but then I'm going to have minus 12 times 2. That's going to give me a negative. And then if I input 4 here, I won't go through the whole process, but you would get a positive. Okay, so you can always check those, but all you need to know is that it's a positive number. And when I know that I have 4 squared times 16 times 3, well, that's going to be larger than negative 12 times 4, and right away I know that's going to be a positive number. So I know that f of x is increasing on negative infinity to 1, and then again from 3 to infinity. Okay, and then I also know that it's decreasing just from 1 to 3. Okay, and that makes sense because I already know I have my maxes and mins. So now I kind of have like another really useful piece of information here to go ahead and graph it. Okay, now last thing is I need to figure out my my points of inflection if there are any, right? And if there's still an x here when you take the second derivative, then there will be a point of inflection. Notice it should also be right in between the maxes and mins. So if I look at this, this is my second derivative. 6x minus 12 equals 0. 6x equals 12, and x equals 2. Okay, now if I go ahead and input 2 back into the original, I'm going to get my answer here for the y value. And notice this should actually be in the middle here. It should give us negative 1. So let's check and make sure. We get 8 minus 24 plus 18 minus 3. Well, that's going to be, yeah, so we're going to have 8 minus 3 is 5. Negative 24 plus 18 is minus 6. And we got negative 1. So we got our point of inflection, only have 1. Point of inflection, right, is going to be 2 comma negative 1. Okay, now to determine concave up and concave down, we just got to look before and after 2. Okay, now that we're at the second derivative test, that's really easy because if we input 1, we get 6 times 1 minus 12 is negative. And then if we input 3, we got 18 minus 12. That's going to be positive. Okay, so then we know that f of x is concave up on, well, 2 to infinity. And then it's concave down the whole time leading up to that. We're going to look at that in a second. On negative infinity to 2. Okay, now we have all of our useful information here, right? We got our point of inflection, we got our maxes, mins, we even have our y-intercept from way back at the beginning of this, right? So now we're going to take all of that and we're going to graph it. So the first thing I would do is go down here and I'm going to say, okay, well, I know that my y-intercept is 0 comma negative 3. I also know that I have a max at 1 comma 1 and a min at 3 comma negative 3 over here, right? I also had that point of inflection, which is 2 comma negative 1. Now, in order to figure out how this graph is going to move, well, if you know the shape of a cubic function, you can kind of get an idea here, right? But you can also look and see that it's increasing from negative infinity to 1, and then again from 3 to infinity, right? And then it's only decreasing from 1 to 3. So that's how I can get the shape of the graph right away like this. Now notice, let's actually go back and get this a little better, but notice it's concave down from negative infinity to 2, and then it's concave up from 2 to infinity, right? So the bigger point being here, we got our max at 1 comma 1, we got our min, and we have our point of inflection, and we're able to graph this just using the first and second derivative tests. We don't have to use a graphing calculator or use Desmos to find this. You can just go ahead and take all this information, and we do all this without the calculator, right? And, if you want to check, you can kind of like check your work to make sure everything corresponds. Well, yeah, it increases from negative infinity to 1, decreases from 1 to 3, 3 to infinity. I got all my shapes here. This looks like a cubic. So now I'm done with this problem.